Just relax. Stuff is.
Can we do yoga after the AP test? Ooh. No, I know.
On your free time.
Candle.
Alright, so let's just refocus. We are on notes number 28, section 9.6, one section, the last section in this chapter. But don't panic, you're going to learn a whole nother chapter before you take your test. Okay, so your test will be before spring break, but we have more to learn in series. I don't know, most books have just one chapter on series. This book split it into two chapters, so we're going to just take a test, one series test, instead of taking two series tests. You wouldn't want to do that. Okay, so we are going to discuss the last test here, which is called the alternating series test. So up to this point, you haven't had any series problems really that had negative terms. Everything's been positive terms. Okay? So now we're going to throw at you what happens, and specifically when you have series that the sign alternates, positive, negative, or negative, positive, so on. Okay? That's called an alternating series, and there's a specific test to use when you have an alternating series, and you're going to really like this one. So the nice thing is, it's very obvious when you have an alternating series, and every single time you have an alternating series, you use the alternating series test, and it's a pretty easy test to use. Okay? So, first of all, just to get down here what an alternating series is, I just explained it to you when I get down your notes. So, alternating series, oops, need to put a dash in between there. So basically this is where the signs of the terms alternate from positive to negative. Okay, back and forth. Then you can start with negative, then positive, then negative, doesn't matter. Now, they could get a little fancy and go positive, positive, negative, negative, positive, positive, negative, negative. So you're not going to see that very rarely, maybe never ever, but that could also be considered alternating even though it's not every other one. Okay? How do you recognize it? So let's just use an example. You notice it has a negative 1, and it has a negative 1 in this case to the n power. This is the part that's causing it to alternate right here. Because when you put 1 in, first time you would get negative 1 to the first, which would be negative 1. And then when you put 2 in, you're going to get negative 1 squared, which would be positive 1. So you can see how the terms will go positive, negative, positive, negative, positive, negative. This is still a formula, just like we had before. So a sub n is just some crazy equation that's generating stuff. But in front of it, you're going to have this negative 1 to the nth power. Okay, now, this part here, this is where it goes, will be negative first, then positive, then negative, positive, and so on. Okay, that's what's caused by that sign. Now that's not the only option to do that. So you could also have negative 1 to the n plus 1. That's another one that would do exactly the same thing. The first one in this case would be positive, then negative, but it's the same idea. It would cause it to alternate. Or we could have negative 1 to the n minus 1. It's another one. All of them would do the same thing. How about 2n? Well, we took negative 1 to the 2n power, where that causes the signs to alternate. Devin,
Yeah.
you're shaking your head no, and you're right. Why not?
Because it's basically like you're taking that negative 1 to the n, and then you're squaring that, which would be
Oh, that's a clever way of thinking of it. Yeah, very clever way of thinking of it. I'm just thinking of what does 2n generate? If you put 1 in, then 2 in, and 3 in, and 4 in for n, what numbers do you get? Even numbers. So you always have an even exponent, so it's always positive. Good. Perfect. So this is another way. There are going to be other ways. Here's one that's really kind of clever. Cosine of n pi. There's no negative 1 there at all. There's not even an exponent. But if you stop and think about it, if you started put, let's say, it doesn't really matter what you start with n. If you started n with 0, you'd have the cosine of 0, which would be positive 1. Then you put 1 in for n, and you get the cosine of pi, which is negative 1. And then you put 2 in for n, and you get 2 pi, which is going to be, you get the idea? So it does the same thing. This one's a little harder for people to see and remember, but once you notice that, you recognize it's alternating. Alright, so once you know you have an alternating series, you can jump right to the alternating series test. And I'm going to just kind of write it out here in kind of simple terms, or layman's term, whatever we're going to call it first. Now, these aren't like the official mathematical terms, but this is what you're going to do, basically, is this is how you go about the process. So, you would cover up the part that causes it to alternate. So it causes the signs to alternate. And take the limit as n approaches infinity of the rest. Alright, so it's very similar to the nth term test. You look at it, oh, this is alternating. You cover up the part that's causing it to alternate, you take the formula part, take the limit of that as n approaches infinity. Now, if it was just the nth term test, what would we be hoping for here in order for this to even possibly converge?
Not zero?
Well, if it was not zero, first of all, what does it mean to take the limit of these terms as it approaches infinity? I guess we got to take a step back if we're not too because nobody really answered.
It tells you what it approaches as the domain approaches infinity.
So the actual terms, right?
Yeah.
So if I take the limit of this stuff and I get 5, what does that tell me? You're going to keep adding 5 later on, right? At some point they're all going to be 5s and you're just going to keep adding 5 and 5 and 5. Is that going to converge? What's the only way it could possibly converge? 0. If you start adding 0 on, then it doesn't change anything. That's what we're hoping for, okay? So if we go back to the very first test we learned, if we take the limit as n approaches infinity and we do not get 0, what is the immediate answer? Diverges. And if you got 0, what was the answer? Try another test. It was a big maybe, try another test. Well, here's the exciting news. In the alternating series test, you're done. If you get 0, it converges, period. Okay? So if you don't get 0, it will diverge. Technically diverges by the nth term test, which you realize, oh shoot, I should have done that first. If I took the limit, I would have gotten not 0, and then it diverged. Okay? But if you get 0, then it converges. So, just to write this down, if the limit as n approaches infinity of the formula part, so we covered up the alternating part of the formula part, if that equals 0, then the series, alternating series, so -1 to the n, whatever that formula is, converges. diverges by the alternating series test. And if the limit does not equal 0, as it approaches infinity of that stuff, then it diverges. And this is sounds a little picky, but technically it diverges by the nth term test. Because that's the reason why you should have done that first and you just didn't think of it. Then it diverges by the nth term test. Okay, so very easy to see when you have alternating series, very easy test to use. Let's do some quick examples here. Bless you. That's an end. Okay, so here we go. First one. Right away, we notice, yeah, this is alternating for sure. So we're going to cover up this stuff over here, the -1 and the n+1. That's what causes it to alternate. And we're going to take the limit of whatever is left over. So we're going to take the limit of this stuff. So it's the limit as n approaches infinity of 1 over n. What is that? 0. 1 over infinity is indeed 0. So what does this tell us? Converges by the alternating series test. Okay? A very similar problem to that. Alright, so here's another quick example. Also alternating, you can see by the -1 and the n+1. We're going to take the limit, so we're going to cover up this stuff here. We're going to take the limit, n+1 over n, as n approaches infinity. What will that be? We're going to use L'Hopital's rule in our head. We're going to get 1. That's just the coefficients there. So this diverges. Why does it diverge? Yes, by the nth term test. Questions?
Like we kind of just start by covering up the -1 to whatever it is. Is it always gonna be that obvious what makes it alternate?
Pretty much, yeah.
Okay.
The only tricky one I showed you was the cosine one, I think. Yeah.
Couldn't it be negative any integer, or any whole number, so -3 or -1/2?
Oh, good question. Yeah, well, you're going to get that. So let's say you have this. Well, you got to play around with it a little bit first. You want it to be just -1 to the n. So -3 to the n, that's equivalent to, I mean, think of this as -1 times 3. So I'll kind of go the long way here. And so that's the same as -1 to the n, and then it's 3 to the n. Yeah, that's a great question. Nobody asked that last hour. I'm glad that came up right now, because you're definitely going to run into that issue. You have to get it to just a -1. So you're going to have to manipulate it. This is the stuff right here you take the limit of. And that's an important part of the problem now, that 3 to the n. Okay? Any other questions? Again, guess, the only thing you watch out for is that exponent. Just because there's a -1 to an exponent doesn't mean it's going to be alternating. We already talked about 2n, even numbers. How about 2n plus 1? What kind of numbers does that generate? 2n plus 1. Odd, right? Put in 1. You're going to get 1. You put in 2. You're going to get 3. So you're going to start recognizing how to generate odd and even numbers there. Perfect. Okay, so that is it for alternating series tests. You've learned all 10 tests. Now, here's the deal. They also in this chapter talk about or introduce the idea that there are different types of convergence. And this only comes up when you have terms that series that have negative terms. So it never came up before, but now it's going to come up. And they want you to distinguish between series that converge conditionally or series that converge absolutely. And there's a nice little flow chart, I think it's good, on page 657 in your book to help you get an idea of what we're talking about here. 657.
Wait, 657 or 658?
57.
Is it the one with the flow chart or the big, like...
The flow chart.
Thank you.
That other table's good too, but this is the one I'm talking about here. It's not a very complicated flow chart at all, obviously. So you see in the picture you have a series. You first decide if it converges or diverges. If it diverges, that's it. You don't have to do anything after that. Diverging is diverging. There's no conditionally divergent or absolutely divergent, just divergent. Okay? Now, the other one, when it says convergent, if it has negative terms, they might ask you to determine if it's conditionally convergent or absolutely convergent. It's just one or the other. And absolutely, it's the idea of like absolute value. Does it converge with a negative sign in? And does it converge when you take the absolute value of it? That would be absolutely convergent. I'm going to show you more of an example here. But that's the idea. Now, you won't actually take this next step unless they ask you on the test, determine if it's absolutely or conditionally convergent. You don't have to just on your own say, oh, now I got to keep going. Okay? It's only when they bring it up. So, absolute convergence means the series converges with the negative signs and without. I think that's just the simplest way to think about it. So you have a series, you're going to test it just as it is with the negative signs in there. You're going to do the alternating series test on it, and then decide what that is. And then you're going to start over, and you're going to pull all the negatives, the part that's causing it to alternate, that negative out, and just focus on that, and then start over. It's no longer an alternating series, so you can't use the alternating series test on it. You use one of the other tests. All right, so for example, go back to this one. We'll do this one here. Start with this. So negative 1 to the n over 1 divided by n squared. So, first of all, we're going to test this. What test are we going to use on that? Alternating series test. We're going to cover up the negative 1 to the n. We're going to take the limit of everything else as n approaches infinity. When I put infinity here, I get 1 over infinity, 0. Therefore, converges. This converges by the alternating series test. If that's all they ask you, does it converge? And we're done. We know it converges. If they they say, does it absolutely converge or conditionally converge? Then we check and we start over. So we start over with this series without the alternating part, without the negative 1 part. So just this. And we test that one. So basically we take the absolute value, and that's what we're talking about, absolute conversion. We take the absolute value of what we were given, and we test that convergence. What test would you use here? You would start with that, you get 0. Does that tell you anything? Nope. So then would you try P-series, right? This is a P-series. Converge or diverge? If it's greater than 1, converges. Okay, so this converges by the P-series. Don't worry, you're going to get a lot more practice in this assignment with them all mixed together. That's what you really need, is to mix them all up and try to figure out what test to use. Okay, so it converged with the negative signs in, and it converged with the negative signs out. So what do you think? Absolutely convergent. Questions on that? Compare that to this one. And you can see where this is going. So it's alternating. One more time, we're going to take the limit of this. 1 over n, we know we get 0, so this converges by the alternating series test. And then if they say, okay, is it absolute or conditional? Take the negative out. So we start over. So I want you to recognize it's a completely different series. And we look at that, just the 1 over n, what will that do? Yes, why? P series. So, what does this do? Conditionally convergent. Make sense? Again, you only do that when they ask you to do that. Don't start trying to do that on every single one. And it only comes up when you have negative terms. So. Okay. Now, one more thing here, this section. And that is, sometimes we're asked to find the sum. So, when are we asked to find the sum? What are the only situations, kinds of series where we're asked to actually find the sum? Add it all up and tell me what you get. Yes, geometric is one, and maybe the other one, maybe would be telescoping. Telescoping, right? Yeah. Okay, so that'd be it. Otherwise, I haven't asked you to add them up, right? After that, just say, would you get an answer or not? So now they're going to say, all right, we know we're not going to really make you add up all of these numbers right now at this point in your life, but let's approximate it. So instead of adding up all the numbers, I want to approximate the sum. Let's just add up some of them. The first 5 maybe, the first 7, the first 12. They tell you how many to add up. Okay? So, let's call this approximating infinite series with a partial sum we're talking specifically about an infinite alternating series. Let's throw that in here. Oops. Okay. So this is all about alternating series today. Oh, I need an and here. And find the error. This idea of error is an important one. And this is not hard. Okay? This is not going to take too long. I hope we find this not too bad. At least not for alternating series. So, let me just show you exactly what I'm talking about here. Okay, so the same one we've been dealing with a couple times here. -1, n plus 1, and 1 over n. We started throwing the terms in, we put 1 in first. We're going to get, -1 squared, be positive, so you get 1 over 1, you get 1. Then when you put in 2, you're going to end up with a -1 over times 1/2, so it's -1/2. Then you get plus 1/3, -1/4, plus 1/5, -1/6, plus 1/7, -1/8, and so on. Now, first of all, we said that this is going to converge, so there has to be a sum, right? We just don't know. We don't want to spend the rest of our life trying to add these numbers up, so we're going to approximate it. So we're going to stop somewhere, and they'll tell you how many to add up. They might say something like approximate the sum with the first 5 terms, let's say, or 6 terms. First 6 terms, let's say. Or they might say to you, find the partial sum S sub 6. Means the same thing. It's telling you how many terms to add up. Those are different ways they can say it. So, 1, 2, 3, 4, 5, 6 terms. That would be it. I would take my calculator. Yeah, you'd be able to use a calculator. It was just fractions, but nobody likes adding up all those different common denominators. But you'd be able to take your calculator and plug in and you get an answer. And it'd be the more terms you take, the better approximation. So, it wouldn't take too many, you get a pretty good approximation. If you had a computer to do that for you, then that'd be a really good approximation. But it's just an approximation. So the next thing they'll say is, find the error. How far off are you from the real value? Or in other words, they might say the remainder. Another way of saying basically the error. How far off are you? So if you add them all up, you get the real value. We stop at 6, we get that value. What's the error? How would you find that? Like how far off are you? How far away is your answer from the real answer? Say it again. Perfect. So we knew what the actual value was, and we could subtract what we just did. That would be the difference, right? And we don't know what the actual is, though. What do we, like visually up here? What else? What's another way of thinking about that error?
When it's 0, or like you would take that value.
When what's 0?
When like the 0.
Oh, I see. If you carry them all and try to figure out when you got to 0, unfortunately, we're not going to get to 0 until we get to infinity. So that would be, what I'm saying? Like, that might take a while to do. You guys are thinking too hard. Just look at that. I don't want to, you don't tell me the answer, but conceptually tell me what did we not add on? Maybe that's the best part. The rest of it, right? Isn't that it? Everything after that, isn't this the error?
So could you literally say say the summation of n equals 7 and then to infinity?
Yeah, but that'd still be too much, right? Because you don't want to add all, you still can't add up all those numbers. So, but for alternating series, it's actually really cool. What's the most that could be? What's the largest possible maximum error?
1/7.
How much? I heard some people say it.
1/7.
1/7. That's cool. Why just 1/7? Who wants to raise their hand and explain to me why it's just 1/7?
It made sense when I said it, but now that I'm thinking about it, I don't know.
Come on, you can do it.
Look at it.
Well, like, no matter how much you take off, you're adding a smaller part.
What do you, Ben? You had your hand up, yep?
Because right after 1/7, you subtract 1/8, and everything after that adds on is smaller than the next. Is smaller than what was subtracted, which means no matter what, you're never going to get back up to 1/7, much less past 1/7.
Beautiful. Does that make sense to everybody? If I add all these numbers up, I'm going to start with this one, 1/7. That's what I got right now. Oh, now I got to take some off. Now it's less than 1/7. I'm going to add some back on. I'm going to add on 1/9. But what I'm adding on is less than what I just took off. So am I back up to 1/7? Will I ever get back up to 1/7? So we know all this added together is basically, at the most, the next term. So this, when you think of this error or remainder, think the next term. So if we stopped here, the next term is just 1/7. This is the largest possible error, or the maximum error. We know it won't be any greater than that. Won't even equal that, right? We know for sure, but we say that it's going to be, the error is going to be less than or equal to that amount. That is so annoying. I don't know. Every day I just live next to the party in the lounge. That's all it is. Party in the lounge. It's a great place to hang out when you're skipping class. So, now let me ask you a question. When you think about error, like how far off you are, you talked about this in science class. You know, it's like plus or minus, like you know what I'm saying? So when you think of error, always think of like an absolute value. Oh my gosh. So if we would have added up the first 7 terms, what would the maximum possible error be? So you guys out there just living it up. Let your phone ring. If we added up the first 7 terms, what would be the largest possible error? 1/8, right? It's always the absolute value of the next one. Because, I mean, I think it's the same idea. It's a little strange when it's a negative number. It's a little harder to understand. But if I take off 1/8, I took off a lot. That's how far off I am. You know what I'm saying? My real answer should actually be 1/8 less. Then I add a little bit back on, and I take some off. It's a little bit, not quite as much, and I keep going. So I will never be more than 1/8 away. Okay? So it's always the next term. It's the absolute value of that next term. That's it. And that's only true when we're talking about, obviously, alternating series like this.
What about, like, if you went out to the 7th term, then you would have the 1/8 added on to another value, so wouldn't it be those two added together? The 1/8 plus 1/9?
Yeah, but you're taking off an 8. So think about it this way. Like, this is the real answer. I mean, this is approximation. My real answer is all this. Okay, my error over here is going to be negative. It's going to be negative 1/8. Now that's a big error. You know what I'm saying? I'm off by an 8. Now I'm going to add a little bit on there, so I'm not off quite as much as an 8. Then I'm going to take a little bit off, but not as much as I just added on. So I'm still, you know what I'm saying? You're never getting back to that 1/8, which was, that's the most you were off. That was your error, your maximum error. Does that make sense? It's only true for alternating. Yeah.
So will they ever ask you to find like the absolute or conditional convergence, or like the approximate the infinite alternating? Oh, I guess not. Will they ever ask you to do that with like a different series test?
They could ask you to approximate a series, or any kind of series. Definitely. And you're going to learn the error process for all the other ones. Well, not all the other ones, but another one. This is the easiest of the two error formulas, so we'll just not worry about that right now. We're just focusing on alternating series today. I don't know. That's not hard, right? That's kind of cool. And you're gonna get a series free response question. Every single AP Calc BC exam ever created had a series free response question on it. Every one. You might get 2, or parts of 2, but you're gonna for sure get 1. And this is a very common question, like part D. Approximate it, now find the error. So, and it's not hard at all. So go.
How many free response questions are on the...
Real tests? Yep, there's 6.
And how many multiple choice?
There's two parts to multiple choice, and they're actually changing the number. So it used to be 28 and 17, so there used to be 45 multiple choice, but they're trying to balance. Because calculator and no calculator. There was 28 no calculator and 17 calculator. And they're trying to balance that out. You'll get more, don't worry about it. We're going to review. You're going to be well
It's not as bad
prepared.
as I thought it was going to be.
It's, like 3 hours and a half, or 3 hours and 50 minutes of just testing time. So
We're gonna be stuck in that room for like 4 hours.
you'll be in there for a good 4 hours.
Oh my god, I'm going to have to do that.
Are we gonna do the thing like we did in stats last year where we fill out the front page ahead of time with all of our personal info?
Yeah, we are going to do that. All your AP classes are going to do that.
Yay. That was so much better.
So that will definitely help.
Wait, that's it?
Oh yeah.
So this is the section we just did, and then I'm going to give you some problems out of the review from the chapter 2, because I want you just need more practice on trying to figure out the converges or diverges when they're all mixed up. So these are additional problems. The first one here on page 661, only do 1, E, and G. So there's parts like A, B, C, D, E, F, G, H, I don't know how far it goes, but only do E and G. Because you got to be good at all of these tests, just to kind of give you a heads up. You kind of learn like the skills to be able to do the series stuff that's coming up next. You develop this bag of tools or skills, all these tests to learn to be able to now use them in these future problems that are coming up in the next chapter. So, this is, out of the chapter review.
It's Pi Day.
Is this like the same assignment?
There's all an assignment. This is I don't know, I gave you like 10 problems out of the alternating series stuff.
I know we're going over it Friday.
Yeah.
Both of them?
Yeah, this is assignment number 28. The whole thing is assignment number 28. It's like 20 problems. Bless you. And Monday is Pi Day.
Yay.
We're going to celebrate it Tuesday.
Yeah.
You guys going to step up and
it's a
We
cited Oilers Day. We had to say Pi Day.
We killed Oilers Day.
Yeah, that was pretty good for
that was a
your
good
first attempt at Oilers Day. Much better than